Okay, this limit, as we try to plug x being really, really big into this 3 over a really big number is tending towards 0. The sign of 0 is going to 0, plus 1 is 1. But then we got a number going to 1, going to a really, really big power. Well, we got a kind of a weird situation here because we think of 1 to any power as 1, but if you have something a little, technically this is going to be not quite 1. So not quite 1 to a big power, well, geez, that can get really, really big. So, it's kind of like not the number 1 to a big power. That's kind of weird. Who knows? Okay? So it's not just as simple as this thing becomes 1. So what we're going to do is, again, like a logarithmic differentiation, but of course it's not logs, but we are going to do this idea of taking the log. But to do that, I can't actually change the problem. So we're going to take e to the natural log of this whole thing, 1 plus sine of 3 over x, all to the x. Same thing, right? E and natural log, they undo each other. Now the reason that I'm doing that is so I can take advantage of bringing the x down front of the natural log. And I'm going to take that another step further because that's not going to help me unless I actually write it in a form that I can use L'Hopital's rule on. And so instead of writing the x times natural log, I'm going to write it as 1 over x in the denominator. So I'll show you here. We're going to have e to the power of the natural log of 1 plus the sine of 3 over x, all, no, I'm sorry, not to the x, but instead we're going to be dividing by 1 over x. Okay, so that's the whole exponent here. So now when we actually try to plug in really big values for x, okay, so 3 over x still going to 0, sine is going to 0, plus 1 is going to 1, but the natural log of 1 is 0, so the top's going to 0 here. Okay, denominator, we've got 1 over x. X is getting big. 1 over really big gets really small. So we have that L'Hopital kind of form of 0 over 0. So we can go ahead and use L'Hopital's rule now. Just a second here. So L'Hopital's rule, the limit as x goes to infinity of e to the, now this gets really crazy, derivative of this numerator. So derivative of natural log is 1 over the natural log, I'm sorry, I meant to say it's 1 over the inside, 1 plus sine of 3 over x, and then by the chain rule times the derivative of this whole inside. So derivative of 1 is 0, derivative of sine is cosine of 3 over x, but I have to use chain rule again because the cosine's inside 3 over x. So the derivative of that will be, now I like to think of 3 over x as 3 times x to the minus 1, so I can use a power rule, and that just gives us then a negative 3 x to the minus 2. Okay, that was just derivative of the numerator divided by derivative of the denominator. A similar thing here, this denominator of 1 over x you can think of as x to the minus 1 and then use the power rule to say, well, that's going to be negative 1 x to the minus 2. Okay. Now we actually get to do some canceling because we've got a negative x to the minus 2 here, a negative x to the minus 2 here, and that leaves us with the limit as x goes to infinity of e to the 1 over 1 plus sine of 3 over x, and times our cosine 3 over x times 3. Now if we put really, really big numbers in for x, we're going to get this being 0. This actually goes to 1, so this whole thing ends up going to, that's 1, this is going to 3. 3 times 1 divided by 1 ends up being e to the third power.